Have you ever encountered a trig problem where they give you several characteristics about a sinusoidal function, and then they ask you to find the expression of that function in terms of sine and in terms of cosine? Well, how do you do something like that? My goal today is to take you step by step through two examples that will show you exactly how to approach a problem like that. Let's take a look. Let's read through this example here. Suppose that a sinusoidal function has the following characteristics. It has a maximum point of 2, 3, and the closest minimum point of 6, -7. Find an expression for the sinusoid in terms of cosine and in terms of sine. In order to begin with such a problem, let's quickly remember again what is general form. The general form of a sinusoid looks like this. Y equals A times cosine B x minus C plus D. And then in terms of sine, very similar. A times sine B x minus C plus D. I have two videos in this channel where I go very carefully over the significance of general form. I will link those videos below so that you can go over them if you feel that you want to refresh your memory. So what I'm going to do right now is to start jotting down all the important components that I was given here. For example, by giving me the maximum point, they have given me the maximum y value, and similarly, the minimum y value. So that's very important. I'm going to go ahead and write that down. So the maximum y value is 3. The minimum y value is going to be -7. I also want to say here that I am already assuming in this video that you have a fairly decent knowledge of transformations and of trigonometric functions. So there are going to be some things that I will not stop and explain because I will assume that you already know that. Continuing, let's go ahead and find the amplitude. The amplitude is going to be equal to m minus lowercase m divided by 2. So in this case, we're going to have 3 minus -7 over 2. That will be 3 plus 7 over 2, which is going to be 10 over 2, which is going to give us 5. Then we're going to go ahead and find D. D, the formula for D, is pretty much the average of the y values. M plus lowercase m divided by 2, 3 plus -7 over 2. That will be 3 minus 7 over 2, which is -4 over 2, which is -2. Now, by having D, we also have the new axis of symmetry of our transformation. All right, then another thing that I think we can try to find right now is the period of our graph. Well, the period was in a sense kind of given to us because see, they gave us 2 consecutive points on the graph, but the points are special, a maximum and the closest minimum. The distance along the x values, along the x-axis between a maximum point in a sinusoid and the closest minimum, that distance, the horizontal distance, is 1/2 of the period. So then, for example, I know that if I want to find the period, all that I have to do is to subtract the x values. So 1/2 of the period is going to be equal to 6 minus 2, which is equal to 4. But then that implies that the period will be twice this amount. So then that means 8, which now allows us to find B, because B is equal to 2 pi divided by the period. And that will be 2 pi divided by 8. When we simplify, half of 2 is 1, half of 8 is 4. We are going to get pi divided by 4. This is very key here. Every time that in a problem like this, they give you a maximum and the closest minimum, all that you have to do is to subtract the x values of those 2 points, and that will give you 1/2 of the period. Always, always, always. All right, so now we have B. All that we have to do is to find C, the horizontal shift, and then to settle the value of A. Now A is always related to the amplitude, but it's not always equal to the amplitude. Sometimes A is positive, sometimes A is negative. If it's positive, that means that we're not going to do a reflection. And if it's negative, then a reflection is involved. That usually depends on the type of information that they have given us. So what I want to do right now in this diagram here is to just roughly plot some of the points that they gave me and some of the information that I just found. But it's really a rough diagram. In no way am I assuming that this is precise. It's just to give you a visual. So D is -2. That means that this is the new axis of symmetry. So we're going to be somewhere here. So this is D equals -2. And then they gave me a maximum point at 2. I'm just going to put a point randomly there. And then a little bit later on at 6, they came and they gave me the minimum point. And I'm just going to randomly place it here. Something like this. Again, actually, I'm going to even place it a little bit lower. But this is not a precise diagram. So I have something like this here, and then something like this. Okay. So what I need to do now is to think, okay, if I have the parent function cosine, and if I now take that function and I shift it to the right 2 units, I am going to match the mountain that cosine always has at x equals 0, right? The parent function cosine has a mountain at 0. So I'm going to take that mountain and shift it to the right to match this mountain right here. So because I am going from mountain to mountain, or from high point to a high point, no reflection is needed. I can do my horizontal shift. I can shift it over to the right here, 2 units. And again, mountain to mountain, no horizontal shift is needed. So then that means that the actual expression will be y equals 5 cosine. B we said is pi over 4 with a horizontal shift of 2 to the right and a vertical shift of -2. And there is the expression, as simple as that. Now, what happens if we want to find the expression in terms of sine? Well, in terms of sine, a lot of the things will remain the same, like B will not change. D will not change. And B will not change because in these discussions, we try to always keep B positive. The one that becomes positive or negative is A. So we without any loss of generality, we can assume that B is always positive. So B and D will stay the same. We're just going to have to go ahead and think a little bit more carefully about C, the horizontal shift, and A, a possible reflection or no reflection at all. So when I go back to this diagram right here, imagine that I try to draw a little bit more of the graph. If I do that, I'm going to have something like here, something like this. I mean, I don't know if it's going to look exactly like this, but I know that sine will have a rising effect like that, a rising effect. And I also know that the axis of symmetry divides the sinusoid in half. The parent function parent function sine at x equals 0 has the same rising effect, just like this, like an S shape, a very long S. So what I want to do is to find precisely this x value. Now in my diagram, it appears as if x is 0. But as I emphasized earlier, this is a rough diagram. I don't know if this is exactly what's going to happen. I need to verify that algebraically. Just because it seems as if the middle is right on the axis, it doesn't mean that is the case. Maybe it is a little bit shifted to the right? So I was just roughly putting a sinusoid together without much thought. So let's go ahead and figure that out. Well, what do we know, right? What we know here is that I have a maximum at 2, at x equals 2, and then I'm going to have the middle somewhere here. And I know that distance between the middle and then a maximum is always 1/4 of the period. Always. The 4 consecutive x values within a period of a sinusoid are always 1/4 of the period away from each other. So let's calculate 1/4 of the period. You remember that the period was 8. That means we're going to have 8 divided by 4, which is 2. What this is saying now is that this, the distance from this x value to here, so this distance that I am highlighting in red, is going to be equal to 2, 1/4 of the period. So then I'm hoping that you can already see nicely that indeed, even though it was not my intention, my diagram was quite accurate, at least this part of my diagram. The middle of the sinusoid is exactly on the axis. If I take 2 and I subtract 2, I get 0. So then, as a sine function, so using a sine expression, no horizontal shift is needed. And because I have the S shape, a perfect S, the graph is increasing right here in this region, no reflection is needed as well. So that means that in terms of sine, we're going to have 5 times sine pi over 4. But since there's no reflection, I'm just going to put x minus 2. And that will be the expression in terms of sine. What I want to do right now is to show you graphically with a very nice illustration that this is indeed the case. Let's go ahead and enter these functions into Desmos. I'm going to go ahead and do that first with the cosine graph. We had 5 and then cosine brackets pi divided by 4. And then here we did have a horizontal shift of 2 units to the right and then minus 2. And you can see the graph right here, right? Very nice. And then we're going to go ahead and enter the other one in terms of sine. 5 sine, then again pi divided by 4, but with no horizontal shift, close brackets, minus 2. And notice how the 2 colors here are different, red and blue, yet we only see one single color right here, and that's because the 2 graphs are identical. The expressions seem a bit different in one case. In this case, in the case of cosine, we did a horizontal shift. In the case of sine, we didn't need to do a horizontal shift. At the end of the day, they both represent the same function. let us now look at this example here. Determine the expression of the sine function with the following characteristics. Now, just sine. The amplitude is 3. The maximum point is at negative pi over 2, 5. And the nearest maximum to the right at 3 pi over 2, 5. So then, let's go ahead actually and get started with a sketch. Let me even extend the x-axis a little bit more towards the left. So negative pi over 2, we're going to place it here. The y value is 5, and that's a maximum. Then the nearest maximum is to the right, let's say somewhere here, at 3 pi over 2, right here. And that's, again, another maximum. So now they're giving us 2 maximum values. So let's think about that. That's quite significant because we know, something that we should know by now, that a basic feature of sinusoids is such that a maximum to the nearest maximum is a full period. Similarly, a minimum to the nearest minimum, the full period. So then that means that in a sense, I can immediately find the period. The period will be this distance right here, which is pi over 2, plus this distance right here, which is 3 pi over 2. Remember that distance is positive. So pi over 2, not negative pi over 2. So pi over 2 plus 3 pi over 2 will give us 4 pi over 2, which is equal to 2 pi. Then that means that b is equal to 2 pi over the period. So b is going to be equal to 2 pi over 2 pi, which is just going to be 1. And that was something that if you actually did pay attention to the period, 2 pi, it was almost obvious. If the period is 2 pi, then that means that there's no horizontal stretch or no compression. Before continuing, I think that this is a great time to quickly remember the general form of a sine function. The general form looks like this: y equals a times sine b x minus c plus d. We already have b right here. What we have to do now is to go ahead and perhaps find d. So let's see. D is going to be equal to the maximum y value minus the amplitude, right? If you think about it, the maximum y value in this case, let me write it down. The maximum y value here on the graph, as they said over here, the maximum y value is 5. If I now subtract the amplitude, that is going to bring me exactly to the level of the new axis of symmetry, which is determined by d. So I'm going to go ahead and do exactly that. The maximum here, I know is 5. That was given to me. The amplitude is 3. So I will subtract 3. And then that is going to give me 2. So then, if I were to just quickly, roughly again, sketch it here, I would have that d is equal to 2. So that's what I have so far. Now let's see. Now I think it's time for us to think about the horizontal shift, about c. So if I were to continue extending this graph, let's say something like this. Let me also extend it a little bit to the left. I would have something that looks like this, right? The graph is rising over here from left to right. I like the rising part because then that means that I wouldn't have to do any reflection, that I can keep a positive. Remember that I said just a few minutes ago in this video that a is always related to the amplitude. The amplitude is 3. So if I if I focus on this part right here, this is exactly the rising part of sine, which allows me to keep a positive a. But then I will have to figure out what is precisely the value of this x, where the middle of this region is. So in order to do that, again, remember that the distance between two consecutive x values within a cycle of the sinusoid is always 1/4 of the period. So in this particular case, 1/4 of the period is precisely pi over 2. If you don't see that, just calculate it. 2 pi divided by 4 will be equal to pi over 2 when you simplify this fraction right here, pi over 2. So going back to this graph right here, now I should be able to find the value of this x right here. The distance between this x and this one, where the maximum is located, is 1/4 of the period, which is pi over 2. I'm going to do that in black here. So there is my dot, that's my point. And this x will be negative pi over 2, which is this one right here, minus 1/4 of the period, so that I take it more towards the left. And that is going to give me very nicely minus pi. So this is exactly the location, the value of that x. It is negative pi. Well, if we take this parent function and we shift it to the left by pi units, then that will match onto the new graph without having to do a reflection. So we are going to have the following expression. Y equals 3 times sine. If you remember, b was 1. And then that really means that we are just going to have x. And since we're moving to the left, that will be plus pi plus 2. So that will be the expression of that sinusoid. Now I could have another expression. Imagine that I follow this decreasing part over here. Because now the graph is decreasing, then what I would have to do is a reflection about the x-axis. So my a will be negative. Now I would have to find this x value right here. But then again, I know that the distance between this maximum point and this one right here along the x-axis, that distance is always 1/4 of the period. So let's go ahead and calculate it. Again in black right here. I'm going to draw an arrow and take you here. This x value will be from negative pi over 2. Since we want to move to the right this time, we're going to add pi over 2, which is going to give us 0. So we are seeing that this x value right here is actually 0, meaning that my graph is inaccurate. This point really needs to be right here on the intersection with the horizontal axis of symmetry and the y-axis. But again, since the very beginning, I said that this diagram was meant to be a rough sketch. Algebra, though, never lies. So now I'm trusting that my algebra is correct. I'm going to go ahead and put the sinusoid together. Y equals negative 3, because now, again, this part is a decreasing part. Negative 3 times sine x plus 2. Again, very quickly with Desmos, we will verify that these two expressions are indeed identical. Let's go and enter the expressions. Y equals 3 sine. I'm going to enter the first one, that we obtained plus pi. We can see it right here. And now I'm going to go ahead and enter the other one. Y, oh no, let me go back. I forgot the vertical shift. So plus 2. There it is. Now we're going to go minus 3 sine x and plus 2. And then again, you can see how nicely the two colors overlap. The very first one here should be red, the second one blue, yet we only see a single blue sinusoid, and that's because they are identical. I hope that you found this video helpful. Again, with consistent practice, you will be able to solve problems just like this very quickly and accurately. Until next time, bye.